and we will, there we go. So today we're going to talk about group work and teams. So our definition of a team, well, a team can be made up of humans or animals, or both. I mean, technically, that's a little speciesist. As far as I'm concerned, humans are animals, but that's a discussion for another day. Usually, we put a team together to achieve more than they could individually. It's the whole purpose of having a team, and arguably, it's one of the greatest technological advancements that humans have. We can work together in teams as well or better than any other animal. For example, a team might be a police officer and her dog, right? Police officer drives to the crime scene because as much as they'd like to, dogs can't drive. And the police dog sniffs out the suspect. Complementary, right? We look for team members that have complementary skills. They go together well. That's really what it means. Just want to make sure we don't confuse that with complementary, which means, you know, to give a compliment. Let's consider the team that we would want for a trivia contest. I'll suggest that for a trivia contest, do we want, well, ask the group. Do we want team members that have similar knowledge? Right? Or do we want team members with a variety of knowledge? Looking at your peer group, would you like to have members all from the computer programming side of our program? Or would you like to have a mix of computer programming people and networking people if we were doing a computer trivia test or trivia contest? I bet you'd like to have some software people and some network people. Sometimes we want team members. Sorry, people keep coming here and I gotta let them in. We have team members with very similar skills. The best example of this would probably be a running race relay team, right? You get the 4x100 meter relay team. Well, everybody on that team has very similar skills, right? They're all selected because they're fast runners. Scaling teams, and this is really important for software developers to understand, right? Can two people do twice the work of one person? Well, the answer is sometimes. It all depends on the task, right? If your task is to move a pile of stones 20 meters, the chances are two people can do that in half the time of one person. But even then, we have to consider how well does that scale? Can 3 people do it in a third of the time? Yeah. But at some point, 100 people, 200 people, you get to the point where you're tripping over each other trying to get to the pile of stones. So no job scales perfectly. Right? I guess the best example of that would be if you have one needle to thread. Clearly, two people can't do that more quickly than one. All right, so very short slide deck for today. Any questions about that slide deck? All right, we'll stop sharing that. Look back. Okay, righty. One more thing we want to talk about, and that is lines of communication. Consider the case where we have a group of, whoop, I got to share that, don't I? My apologies. Let's get that sucker shared. There we go. All right, so consider the case where we have two people in our group. Well, pretty clearly there's one line of communication. Let's see if I can record that fact. Where's my little text guy? That is one, right? One line of communication. Now, when we go up to three people, we have 1, 2, 3 lines of communication. That makes sense. 3. 4 people. 1, 2, 3, 4, 5, 6. 6 different ways that our group can communicate. We go to 5 people. 1, 2, it gets hard to count, eh? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 ways. Now we have this pattern. 1, 3, 6, 10. Are there any big fans of Forzina here who can tell me what the formula for this guy is? See if I can get my chat window up. I can't get my chat window up. I'm sure that there's a way to. So if you know the formula, you'll put up your hand, or I guess unmute and jump in. Okay. Well, I don't know about you, but I'm really bad at guessing these formulas. So I'll tell you the formula. The formula is n times n minus 1 all divided by 2, right? Where n is the number of participants. Let's test this out. So whoops, what do we have here? For the first, okay. For our first guy, we have 2 times 2 minus 1 all divided by 2. See if that works. 2 times 1 divided by 2 equals 1. So that's pretty good. Let's try the case for 3. 3 times, whoops, 3 times, all right. 3 times 3 minus 1 all divided by 2. So that's going to be 3 times 2, 6, divided by 2 is 3. Let's jump all the way to the end. 5 times 5 minus 1, all divided by 2. 5 times 4, that's 20, divided by 2, 10. So for the first 5 cases, our formula holds. So I think we can have some pretty good confidence that this formula is correct. If we were to graph this, it's going to be exponential growth. Right? If you think back to your high school math, we can expand this out. It's going to be n times n minus n all divided by 2. So n squared. And because it's a square term, it's going to grow quickly. Let's see if I can make a really bad attempt, or make an attempt. Be a good attempt. The results might be bad. If we graph this thing, it's going to look something like this, right? Exponential growth. Kind of like what we don't want to see with COVID. We saw it at the beginning. We don't want to see that anymore. This exponential growth. All right, let's stop the sharing. All right, that brings us to the end. Okay. Great. So now I can see the chat window where some people offered some solutions. The first one was n exclamation point. For those of you who may not recall from your high school math, that's n factorial. And that's, for example, 2 factorial is 2 times 1. 4 factorial is 4 times 3 times 2 times 1. Not quite. Another question was, is this a combination? No, it's not. It's not a, actually, is it? That's a good question. I haven't taken combinations in optometrics in 30 years. So I'm going to take that one away because it does kind of look like a combination, but I don't think it is. But let me make a note of that. And I'll post that in a message to everybody. And then finally, we have the correct answer, n times n minus 1, all divided by 2. So good work on that. That brings us to the end of the formal content. I'm going to stop the recording now, open it up for questions and maybe a little bit of discussion. All right. And we'll talk about, actually, before we do that, let's talk about the assignment for this week. We go over to eLearn here. Sorry, Canvas. Let me share that Canvas. All right, here's our Canvas page, modules, week, scroll down, boop, boop, boop. Week 7. Here is our assignment. Submit 1 to 2 page report outlining the best software for a group to work virtually. Turns out this is a pretty relevant topic right now because a lot of you, we're all working virtually as groups. Right now, we're using Zoom as our tool. And Zoom's pretty good for the lecture meeting, but it might not be the best tool for a group of 4 software developers to collaborate. So I want you folks to do some research based on your own experience and come up with a recommendation of the tool. In the past, we've had some international students suggest that in different countries, what tool is best might be different. So if in your group you want to say, in India or in Russia or in Pakistan or in New Zealand, this is the tool that would be best and why it would be best. Perfectly all right, perfectly cool. In our next session this week, we're going to have time devoted to working on this assignment. So you can, we'll talk about that in the discussion in a minute. So there's our assignment for the week. All good. Let's stop sharing and stop recording.